Grade 11s, we would like to review all the financial things and talk through the thought process that you would make in order to decide what formula you would use with each one of these problems. The first problem, you make a deposit at the end of each month. So I am seeing an annuity. First of all, for 8 years in an account that pays 7% per annum compounded monthly. After 8 years, the amount is $13,500. So you are saving towards a future value or amount, either one, and the word happens to be there, but this is an amount problem from annuities. So we know the formula that we need to use. Our formula is R1 plus I to the N over I. Let's check if our I and our N need to be adjusted. The I is 7% and it's compounded monthly. The N is 8 years monthly. And so 96. We know the amount. You want to know. So when the amount is $13,500, some of that is your investment and some of that is interest. And we want to find out how much you've put into it. So knowing the final amount will allow us to figure out the interest. So here we go. 13,500 is the total at the end of those 8 years. Our regular deposit, not sure. 1 plus 0.07 over 12. I'm going to continue to write this as a fraction so we get exact answers. 96, subtract 1 over 0.07 over 12. To get R by itself, we're going to multiply both sides by that denominator and divide both sides by the nasty square bracket. And we will get an R value. I wouldn't normally write this middle step, but some of us are having trouble with our calculators. So 7875 over 0.747826, blah, 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 blah. My R value is approximately 105.31. So I have invested 105.31 for 8 years monthly. So my investment is $10,109.76. So I have 3,400-ish, 3,300 and some odd in interest, but my investment has been $10,109.76. Next problem. Colin asked his Uncle Tony to loan him $500 for 2 months at 20% interest. Tony is just an absolute crook. How much does he owe him in 2 years? So first thing I see is that this is a one-time deal. Colin isn't paying him back monthly. He is doing it all in one shot. So with a one-time deal, no mention of monthly this or that or regular payment this or that, we have two choices. Simple or compound interest. Now, besides the fact that I have an uncle in the problem, we don't see the word compound anywhere. So if it doesn't mention compound period, then it must be simple interest. So the formula that we have for simple interest is principal times rate times time. Colin took a loan of $500. The rate is 20%. 2 months, it's supposed to be in years, so we will type the time in as 2 over 12. The interest that Colin owes him is $16.67. So the total amount will be the $16.67 and the loan of $500. $516.67, or get his legs broken. A loan of $10,000 at 10.8% per annum compounded monthly may be repaid over 48 or 60 months. How much interest would be saved by repaying the loan over 48 months? So, two things. I first of all see that there are regular payments over 48 or 60 months, so it is an annuity. And then from there, I need to decide whether it is a present value or an amount problem. Present value is something you have right now and then pay it off, or right now and pay yourself. Any loan, like this one, would be a present value problem. So our formula would be, and you know that I look this up every time just to make sure I get it right because they're so close. So the loan is $10,000. The regular payment is what we want to know. So the first one we're going to do is the 48-month scenario. Regular payment, we don't know. The interest rate is 10.8% compounded monthly. And it is going to be, for this particular scenario, 48. Over the adjusted interest rate. Remember, when you want to get R by itself, we're going to have 10,000 times. And we're going to do the whole thing divided by the nasty square bracket, which is 1 minus 1 plus decimal 108, 12. $257.49. Now it does take me a second to type it in, but I do it all in one step. There should be very little rounding error. So for the 48-month scenario, you are paying $257.49 for 48 months. So the total that you're going to pay is $12,359.28. Let's compare that to the 60-month scenario. For this one, it's also a present value loan, where the loan is $10,000. The R is going to be different for this one. The interest rate is the same, but we're going to do it over 60 months. Same idea. To isolate R, multiply both sides by I, and divide both sides by the nasty square bracket. Is $216.43 a month. Now that's less, but you're going to be paying it for longer. So the total paid is $216.43 times the 60 payments gives us $12,985.69. How much interest will we save? the larger amount, total, subtract the smaller amount, which is the difference in interest, will be $626.41. Becca lends Nick $75 for 8 months at 10% per annum compounded monthly. How much interest does she earn? First thing I need to determine is whether it's an annuity or a one-time deal. It appears to be a one-time deal. There's no mention of paying it off monthly. I don't know if that's the official financial wording, but it's either simple or compound interest when we're not paying it off regularly. And we need to look for the word compound to determine which it is. There it is. Compound interest. So the only formula that we have for compound interest is this one. She lends him $75. So we want to find out what his total loan will be worth after that amount of time. He is 8 months, $75, 10% compounded monthly. So we're going to adjust that 10% to a monthly rate. He is going to have that loan for 8 months. So our number of compounds will be 8. And here will be the total amount of the loan. $80.15. The interest that Becca will earn is $80.15. Subtract the $75, which is $5.15. Connor is shopping for a new car. He can afford to make a down payment of $4,500 and finance the rest over 48 months. A monthly payment of $525 will fit into his budget. Connor can borrow money at 10.9% per annum compounded monthly. What is the maximum price, including taxes, Connor can afford to pay for the car? So, first of all, we need to decide what type of a problem this is. Is it a one-time deal or annuity? This is not a one-time deal. We're going to be paying this off monthly, so it is an annuity. After you've decided whether it's a one-time or an annuity, you need to decide whether it's a present value or future value problem. We also use the word amount. If this is a loan that he is wanting to use, it is a present value problem. He wants the money now and pay it off. He is not saving towards a future goal. So it is a loan. It is a present value problem. So let's see what he can get for a loan. He can have regular payments of $525. He can borrow money at 10.9% per annum compounded monthly. So the I that he can manage is that. He is willing to pay, or they're willing to give him perhaps, 48 monthly payments. So what type of a loan can Connor get for that? It's present value if it's a loan. R 1 minus 1 plus I to the negative n. $525 each month. Adjusting the interest rate for monthly. And I on the bottom as well. There we are. The loan that he can get, when we type that in very carefully, is a $20,351.21 loan. He also has $4,500 that he can use towards it. So his total purchasing power is $20,351.21 plus the $4,500 that he comes to the table with $24,851.21 is the total value that he can afford. $24,851.21. I think he can get nicer than a Saturn. Next problem, Graham deposited $200 at the end of every month in an annuity. Well, there it is right there, annuity. We also know regular deposits deposited at the end of every month. We have an annuity. And now we just need to decide whether it's a present value or a future value. He is saving this at the end of every month. At the end of 5 years, something happens, and then he deposits for a little bit longer. What is the amount? So we've even told you what kind of a question this is. It's a future value, but if you were making regular deposits towards an end goal, it is a future value problem. So we have future value or amount is R times 1 plus I to the n subtract 1 over I. So this is the most important thought process, is that you get the right category and then the right formula to match your situation. So what's going on here? He deposits at the end of every month at a certain rate, and at the end of 5 years the interest rate is increased. So we're going to consider this like two different problems. So for the first leg of the journey, really, so for the first 5 years we have a certain situation. And we're going to just consider that one amount problem. So for the first 5 years, your amount is $200. Your interest rate is .065 adjusted for monthly for 5 years is 60. And then .065 over 12. So for the first 5 years, she makes all of those deposits, and the total amount, very carefully with your calculator, is $14,134.79. Then for the next 7 years, two things happen. Number one, this amount that we earned for the first 5 years continues to sit and earn interest. So this amount, $14,134.79, is like a compound interest problem. It's going to be in that account still, but now it earns a different rate. And it's going to sit, and it's going to earn 7.75%. And it's going to sit there for 7 years, which is 7 times 12, which is 84. So that amount that we earned for the first 5 years sits and ferments, basically, and it becomes $24,273.73. Deep breath. But Graham continues to make regular deposits into that new rate. So he is going to continue to deposit $200 at the new rate for 84 months. At the new rate, there we are. So he continues to have an annuity, and that totals $22,213.29. So the amount from the first 5 years gives him a total of $24,273.73, and the 7 years at the new rate is $22,213.29. So his total is $46,487.02. There's a review sheet in your booklet that I gave you with some slightly different wording, also pages 532 to 537. Make sure you grab a selection of problems, simple and compound interest, as well as annuities, looking at present value and future value. And you also need to be comfortable with the graphing calculators. Let your conscience be your guide.